We just talked about the space-time assumption principle, okay? When two well-supported theories contradict, don't question the theories. Find the hidden assumption both are silently standing on. And then I pointed out to myself something that stopped me cold. The two biggest theories in all of physics directly contradict each other, which means the space-time assumption principle isn't just a historical lesson about Einstein. It might be the map to the next Einstein move. Right now, unsolved, sitting in plain sight. General relativity describes the large scale universe, gravity, space time, the structure of the cosmos, how massive objects bend space and time around them, how galaxies form, how black holes work. It works perfectly at that scale. It's one of the most precise, verified theories in the history of science. Quantum mechanics describes the subatomic world, particles, probability, the behavior of matter at the smallest scales, the observer affecting the observed. Wave functions collapsing into definite states. It also works perfectly at that scale. Also, one of the most precisely verified theories in the history of science. Put them together mathematically and they break each other. Not slightly incompatible, fundamentally. The equations produce infinites. The frameworks contradict two perfectly working theories that cannot both be true in the same universe. Or maybe they can. Maxwell, Galileo. Oh, okay. Most physicists have been questioning the trees. String theory tries to extend quantum mechanics to explain gravity. Loop quantum gravity tries to quantize spacetime itself. Multiple approaches, decades of brilliant work, enormous resources, all of it focused on the trees. Paul, why do you keep saying trees? Stick with me. The spacetime assumption principle asks a different question. What are both theories silently standing on? What assumption is so fundamental to both general relativity and quantum mechanics that neither one states it? Because it feels like ground not claimed. That's the soil question. And here's what's genuinely interesting. The question is still open. Nobody has definitively identified the shared hidden assumption that both theories depend on. The soil hasn't been found yet. I want to be careful here because this is speculation, it's not settled science. But some serious thinkers have pointed at candidates. Both theories assume a continuous space-time. What if space-time is actually discrete, granular at some scale too small to measure yet? Both theories assume the observer is separate. Hold on now. Hold on now. um, both theories assume the observer is separate from the system being observed. Oh. Oh. What if that separation is the assumption that breaks? Both theories assume causality. That cause precedes effect. What if that's the load-bearing assumption neither has questioned? These aren't answers. They're suspects. The actual hidden assumption, if the space-time assumption principle applies, if you haven't seen this video, it's the video right below this one, most recent to this one prior. The actual hidden assumption, if the space-time assumption principle applies, is probably something even more fundamental. Something so obvious that stating it feels unnecessary. Something both theories depend on without knowing they depend on it. The way time ticking equally for everyone felt obvious before Einstein questioned it. I want to be straight about something. Identifying that the principle applies here is not the same as finding the assumption. The feeling of insight, the whoa moment, when you recognize the pattern, that's not the evidence. Einstein's move produced specific testable predictions. Time dilates by this precise amount. That could be checked. The next move in physics will it require the same discipline? I think about measurement and the division that it is. Anyways, the hidden assumption, when found, will it be able to produce specific predictions that can be verified? General relativity and quantum mechanics. Two perfectly verified theories, direct contradiction. Is this ringing a bell? Maxwell, Galileo? A century of physicists questioning the trees. The space-time assumption principle says the answer isn't in the trees, it's in the soil. The hidden assumption both theories are silently standing on. So fundamental, it doesn't feel like an assumption. So obvious, nobody has thought to question it yet. That's where the next Einstein move lives. Not smarter theories, but deeper soil.